So this is number 1, and this is your answer. Everybody good on number 1? Number 2. This is a right triangular prism. A picture was not provided, but I went ahead and drew one here. What was nice here is they actually described, so the height of the entire prism is 32. The base height of the triangle base is 12 inches, and then the base length was 18. So again, because it's a right triangular prism, you're going to do, for that formula for the area of the base, 1/2 base times height, or base times height divided by 2. And the area of the triangle base is 108 inches squared. Then from there, I'm going to go ahead and plug that base into my volume formula. Area of the base times how tall the prism is, so 108 times 32. And the final volume of this right triangular prism is 3,456 inches cubed. Remember, the units are always cubed. You might also see it written as cubic inches. Either way, so inches to the 3rd power or cubic inches. Number 3, this one was a right cylinder. So here I labeled everything. Notice they gave me a diameter. I needed to turn that into a radius by dividing it by 2. Because remember, the formula for volume of a cylinder is pi r squared height. So I'm just going to plug in, my radius is 7, my height was 30. Multiply those numbers, left in terms of pi, it's 1,470 pi. Now, on the test, just read the questions. Because you're using your calculator, they may also tell you, leave your answer rounded to the nearest tenth or something like that. If that were the situation, then you would have multiplied 1,470 times pi, or touch the pi button, and then round your answer. So just read the instructions when you take the test next week. This next question, this is a nice standardized test question. You might see something like this on an SAT, a PSAT, places like that. So here it's telling us that we have a cylindrical beaker, and we also have a rectangular pan, and they're filling it with water. They want to know that after you fill the cylinder, once you fill that beaker, if you were to pour that beaker into the pan, would it overflow? So in order to figure out would it overflow, and I'm going to change this, I'm not going to ask for the height of the water, I'm just going to ask how much cubic space would be left. So here I'm going to find the volume of the cylinder, pi r squared height. That volume is 300 pi. Now, if I didn't use the pi button and I just multiplied 300 times 3.14, notice the volume of that beaker is 942 cubic inches. Once I do the volume of the rectangular pan, that only gives me 378. So it's not going to hold nearly as much as my beaker. So yes, it would overflow because the beaker holds 942, whereas the pan is only going to hold 378. Once you subtract these, this is how much it would have overflowed. So we're not going to find the height. Now, if it asked you to leave it in terms of pi, then you would have just left it like that, because we wouldn't have subtracted 378 from 300 because of the, it doesn't have a pi symbol. So this is a nice standardized test question. Now let's go through the homework. And I'm going to zoom into each one so you can see the work. So here's number 3. So for number 3, it's not asking me to find just the volume, it's actually taking it a step further, and it wants to know how many 3-inch cubes could fit into that box. So I actually need to find the volume of the cube and the volume of the box. Once I find those two volumes separately, then I divide them. So a shortcut formula for volume of a cube is just side to the third power. So my side length of my cube was 3, and this is an S, not a 5, is 3 to the third power, and that's how I get 27. The volume of the box, you're going to multiply area of the base times how tall it is, or if you recall from middle school, volume of a rectangular prism is just length times width times height. So you multiply 15 times 9 times 3, and that's how we get the 405. So now to figure out how many cubes were in there, we have to divide those, and that's how we get 15. Now for numbers 4 and 5, these are like complex figures. So what we needed to do was separate them into two smaller rectangular prisms and then find the volume separately. So for number 4, I went ahead and divided my rectangle up here and then down here. Now you could have divided it differently. You could have probably gone down this way, but your final answer should have been 20 units cubed. So again, it doesn't matter how you divide it up, just the final answer would be important. The next one looks like an upside down T. So again, I found the volume of this one first. It was 8. And then I found the volume of, looks like the top part of the T, and that was 10. 8 plus 10, 18 units cubed. Number 7. This time it's asking us to find the volume of these prisms and the cylinders. So number 7 is a right triangular prism. So my base shape is a triangle. So I'm going to find the area of this triangle. Remember, it's base times height, divide by 2, or 1/2 BH. So 10 times 7, divide by 2, 35, and then times it by the height. I went ahead, this whole thing right here is the base area. So it's 1/2 base times height, which was 7 times 10, and then times the height of the prism. This is the height of the entire prism. So 175 inches cubed. Number 8, here's a rectangular prism. Again, area of the base is this rectangle, so 4 times 2, and then times it by the height of the prism. Again, remember, you could also have remembered from middle school, just remember it's length times width times height. Multiply these 3 numbers. So 12 meters cubed. And number 10, now we're going to do the 2 cylinders. So again, our formula for volume of a cylinder is pi r squared height. So again, they gave us a radius and they gave us the height of the cylinder. So just plug those 2 numbers in, and then left in terms of pi would be this. But notice in the directions up here, they said to round your answer to 2 decimal places. So this would have been what they were looking for. So again, on the test next week, which is a week from today, just read the directions or look at your multiple choice answers. Number 11, this time this is a diameter, this 10. So I have to divide it by 2 to make it into a radius. So then I would plug it in. Left in terms of pi, it's 400 pi. If I were to use the pi button and round it to 2 decimal places, 1,256.64. Pretty good. All right, next. Now, number 14 was a bit challenging. So for number 14, notice that they said to first sketch it. So here is my picture. I labeled it, but notice the dimensions are in different units. So they said the height was 3 feet, and then they said the width is 11 inches, and then the length was 7 feet. We need to make them all the same units. So what I did was I made the feet into inches. It's easier to convert because you just multiply when you make a bigger unit smaller. So I changed the 3 feet into 36 inches and the 7 feet into 84 inches. And then I calculated it over here. So if you left it in terms of inches, it would have been 33,264 inches cubed. But if you made the inches into feet, if you converted this instead, then it was 19.25. So either way. All right, so then now 15, 16, and 17, we're working backwards. They've already given us the volume on all 3 of these calculated, and we're looking for a missing piece. So notice number 15 is a present, and it's a cube. So what we need to do here is set 1,000 equal to x times x times x. And then when we go to solve this, what we're solving is 1,000 is equal to x to the 3rd power. To solve this, we have to cube root both sides. And then we had to figure out what number times itself 3 times, gives me 1,000, and that would be 10. For number 16, this one was challenging because this was not a right triangular prism. So what we needed to do was take this base, this triangle piece on the top of the cheese or the base, and turn it into a right triangle. As soon as I take and draw in my altitude, I've now formed a right triangle. I'm going to take this 5 and split it into 2.5, 2.5. And now I did Pythagorean Theorem over here. And then this height, which is right here, which I need it because I need to do base times height, divide by 2 to get the area of the base. My height becomes 8.65. Now, when I did it in the formula, I left the whole thing that was on my calculator. So if you didn't, if you rounded it, then your base area might have been a little bit different than mine. But this is the area of the base. And now I'm going to multiply it by how tall the prism is, or the piece of cheese, and that's x. So then I'm just dividing the volume by the base to get the height, which is 2.08 centimeters. The last one is a cylinder. Again, they gave us the volume already calculated, so I needed to plug it into pi r squared height. Notice this x is a diameter. To make it a radius, divide it by 2. So that's why when I plugged it into the formula here, it's x over 2. So then if I take this step here and show you what happened to it, it's 128 pi equals pi times, when I square it, it becomes x squared over 4, and then times the